Well, my friends, here I bring a new article titled Physicists Discover a Completely New Type of Quantum Entanglement. So I just want to highlight some of the key points that these researchers are mentioning in this article. Just to start, this research was developed in the Brookhaven National Laboratory, which is located in United States, and they are very focused in developing the quantum entanglement. The point is that, as we know, the quantum entanglement can be performed in quantum particles. It means very, very tiny particles of the order of 10 to the minus 9 or 10 to the minus 10 meters. So in this sense, we can just distinguish a few particles that can fit this range of distance. And these particles can be, let's say, electrons, photons, atoms even. There is people which is also possibly considered, let's say, nanoclusters, possibly. So the point is that in between the curiosity of researchers, they try to see if they can entangle some other particles different than the regular particles, because even photons can be entangled also. The point is that they just start incising very energized atoms. As you know, the atoms are composed of a nucleus and electrons. So the point is that when you energize these atoms very highly, and then you make it to transit very long term and then collide into surface which is measuring what of the initial atom started. So at that point, you just can know the atom, like say the few atoms that are still on, or just whatever that has been resulted of the collisions at the path the atom has to pass before getting the colliding of the surface. When these researchers start making this testing, they found out that at the measuring surface, they recorded a wave that was not irregular, that was not unidentified form or very strange form, very strange shape. No, they found a regular wave. And as they started with a couple of atoms, let's say, and atoms that can interact with each other, make to fit the experiment to be a kind of atoms that are of opposite charge. So if you have opposite charges, everyone knows that they interact much better in between. So the closeness among these particles that are opposite in charge more or less generated the same fraction of wave at the surface of distinction. When they noted this, they just started to conclude that this atom indeed was at the end one single atom. So somehow they fused the positive and the negative charge atoms fused somehow to provide a very distinguishable wave, which they identify like a quantum entanglement, that for the first time is assigned to different kind of particles. Previously, the entanglement was found to be among the same kind of particles, like say 2 photons, 2 electrons, but now the particles that are interacting and indeed are possibly entangled are different nature. And they assume this because the interference in between these tiny particles, the interference is constructive. So instead of destructing each other, they are constructing to generate the same wave, or to generate the wave which is the summing of the two contributions of atoms. Finally, this kind of research can be achieved, and they are demonstrating at the accelerometer in this lab that I mentioned, which is the Brookhaven National Laboratory, BNL. Very, very interesting this result that they found out, because it's counterintuitive considering what happened before in the field of quantum entanglement. And considering that they found, like, let's say, atoms is heavier than the regular electron, despite they are behaving like quantum particles, they not necessarily can interact at the quantum level as they did with the entanglement. Why do I say that they are quantum particles? Because they can characterize with quantum features. I could say that the level of energies of this particle are quantized. As I can assign this particle entirely to this kind of behavior, I simply assign this particle is a quantum particle. So the point is that according to what they found, these quantum particles are interacted quantumly, and this quantumly interaction is entangled. So very interesting to the researchers that further can want to perform this kind of research, or let's say try to replicate what they found here. Because it's very interesting. It's like an ether interaction that is entangled, because they are different nature of atoms. The bad news, let's say, is that the only way to find this kind of interaction is in very, very energetic, very high energy environment, which is not found everywhere in the world, and which is just possible, let's say, a few places in Europe or the United States. So you need to collide very, very energetically to find this kind of interaction at the level of energy that they say, okay, as we are so energetic and we are so close and we are with the charge to possibly interact, yes, they interact, they entangle, and they tell you this by the wave that they are generating in the surface of resolution at the moment that the particles collide. So I just wanted to mention this research because I think it's gonna be very well mentioned. So, well, guys, I invite you to keep pending on this channel. I invite you to keep pending on to follow me, to follow the channel, the content, to support us. And we are going to keep you updated about what is coming in this new field. Very, very interesting. That every day is just making it more attractive to everyone in the world. Quantum computing is a kind of counterintuitive field, but of course, if you make more or less, you can try to get some point that of course will make you to be like, okay, this field is very interesting. So if you follow this channel for sure, chapter by chapter, you will find that the articles are more or less meaning sense, and it will give you the sensation that you understand. And of course, this is very nice feeling. So I invite you to keep pending on us, to keep pending on the channel, the content we are publishing. We keep on touch, okay? Ciao.